Good evening. Welcome to tonight's webinar, Exam Readiness Further Mathematics, brought to you by Texas Instruments Australia. My name is Frank Moyer and I'm your host for the evening. And now it's my very great pleasure to introduce our presenters for tonight. Firstly, Roger Wanda. Hi, Roger.
Hello, Frank. Hello, everyone.
Hi. Roger has extensive teaching experience also in a number of different settings and also as a maths teacher educator who has presented at many national and international conferences. So without further ado, it's over to you, Roger.
Thank you, Frank, tonight. So welcome to everyone. And just to let you know who's speaking to you and when, this is me. A little bit about my background. And I'm starting tonight's webinar. I'll go for the first 25 or 30 minutes, and then I'll be handing over to Brian Lannon, who will take you through to the end and some question time. Well, to take a look at what we're going to be doing this evening, here's an overview of what we hope to cover in the webinar. Now, in our examples, while the VCEE has decided we cannot show you the actual past paper examples, we hope to give you a flavor of what students may need and access to get the most out of their TI technology. Well, we will look at the examiner's reports in a minute. We're also going to look at some steps for preparing your calculator. And when we say your, we mean yours and your students, obviously. We'll take a look at some of the features of data analysis. Recursion and finance will be looked at as well, as they are now part of the core. We'll briefly discuss some additional links and TNS files for the option or the module topics, which you will have in the exams, and where to find more exam prep materials. Well, first of all, to refresh your memory regarding the examiner's reports, we'll just click on to examiner's reports and have a look at the VCEE site. Now, I'm not going to go into the particular section. This should be a page that's familiar to all teachers, but if it isn't, just note that if you simply Google VCEE, further mathematics, examination reports, you'll get to this page very easily. And for each of the past years, and we can see here, there are quite a few listed down, any number of past exam papers are available to you in a PDF form, but also the examiner's reports. Now, the examiner's report often contains individual statements about particular questions from that paper, but also some global statements about various trends and things that they think students did generally well on and things that they would recommend that students pay close attention to. And there is often some repetition in that from year to year. Some of the same things still get ignored. But for those of you who are teaching for the first time this particular subject, it's really a good idea to have a look at what the examiners, the committee that will be marking the students' papers, have to say about what some of those typical errors happen to be. Now, just at the top here, under previous study designs, where I'm showing my cursor, there's a salient reminder of how the course has changed in going to the new version started this year, as we'll see in the subsequent slides. However, the examiner's reports still are very, very useful for that purpose. So we'll just close that tab and go back to this page and take a look now at the next slide. And these are some of it's just a summary of some of the areas of concern that the examiners formed from the 2015 first examination paper. And then here are the areas of concern for the 2015 paper. And this has been compiled by Brian as a as a summary of what he's read in the examiner's reports, and it possibly would be a good thing for teachers and students to be doing as well, just to get an idea of what some of the concerns have been about. And some of these concerns we're going to be addressing as we go through this evening. Just as a reminder, the structure of Exam 1 for 2016 has 24 marks attached to the core. And in Section B, for the modules, any 2 out of those 4 and 16 marks associated with that. So you have the obvious breakdown of the required time that you're going to be referring your students to. Similarly, for Exam 2, we have 36 marks and 24 marks, respectively, for Sections A and B, core and modules. So very heavy emphasis, obviously, on the statistics and the recursion and financial modeling. We'll take a look now at some of the things that you might do to prepare your calculator. These are good tips for your students to have. First of all, let's take a look at the operating system. I'll bring up on screen a TNS file that's quite empty at the present time. If we press Home and go to 5 for Settings and 4 for Status, just a good idea for the students to be aware of what operating system they have. And this might sound silly to a number of you whose students are using the same calculator that they've had in their possession, but we know that at a number of schools, excuse me, students are only getting access to maybe the school calculators as it's getting close to the crunch time. And they might find that some of the machines that they've got are still back on operating system version 3 or version 2 or something like that. And obviously the things that I'm going to show you tonight are best accessed if you have the operating system up to scratch. So 4.0 and up is fine. 4.0, 4.2 should be quite adequate for this year's exam and retaining all the important features that we are going to describe tonight. Then if we want to escape from that and go back to the same document and take a look at the settings. Well, in the settings, once again in the menu, if we go to 5 for Settings, and now to go to 2 for Document Settings, you notice we have a variety of those that need to be adjusted. And in further mathematics, it's recommended generally, this is going to vary from problem to problem, but generally making sure that they change the angle to degrees, especially if they're doing the trigonometry option, the one that involves measurement. And that's found here. I'll just click to the right there and that you choose degrees. I'll just press Escape and get out of that and go back to the calculation mode. That's another one. To change from automatic to approximate is probably a good idea. Also, one other little trick, if we go back to we escape from there and go back to that home screen, changing to the diagnostic mode is an important one for their statistics work. And if you open up a data and statistics page, now of course this doesn't have any lists, so we get a screen that looks like this, no lists in the problem. Well, that's quite true. But if you on the computer right click, and if you're using the handheld, a control menu, you will get an option to go on to the menu now. You get an option for settings, so it's just on the menu, not control menu. But you get an option for settings, and in the settings you have a chance to turn the diagnostics on. If you click this box here, then what that's going to allow is for the R-squared statistic to appear whenever you are doing something with linear regression. And because that's often asked for in a problem, if that's on all all the way. That'll just take one less worry out of the way for the students. Many of them have that on, but of course, if they're using a borrowed calculator, etc., these are tips to remind the students about a machine that they maybe only acquire a week before the exam. That's reality in some of our schools. We know this. And so if you make a summary of this or give your students access to this webinar, they have a chance to go back and look at this in their own time. So
and
I'll just escape and...
That'll remain
Thank
checked,
you.
won't it, Roger?
Yes, it will. Yes.
Yeah.
Yes. So as long as it's in there, and it stays as a default for the document, then it's there, throughout the duration of their using that particular document. So that's an important one. Okay. I'm going to go back to the PowerPoint now and continue on. So we've taken a look at the settings, changing the angle, the calculation mode. This is just a summary of what we've done. One thing that I'd like to do now is to look at the fact that there are so many TNS files that have already been written that you as a teacher and your students can certainly use and download, and some of them are worth having on their machines so that when they go into the examination, if they see a problem that's parallel to one of those, they can just go in and do some altering. And we're going to take a look at a couple of those. First of all, to see where those pre-written files are located, where some of them are. This is not exhaustive, but let's just take a look at where some of them are. And on the Texas Instruments site, the Australasian site, we have a page. You can notice where that is on the webinars. And in fact, you may have found out about our webinar and past webinars through this. This particular tab that's open when you get into this at first is for the upcoming webinars. And so tonight's webinar is there at the top, and the other ones are scrolled further down. But if you click on Demand, you have a whole history of the past webinars. And I'm just going to bring this down to the webinar that was given at this same time last year. So we go back in time to about here, and we can see that we're looking at the 2nd of September. There we go. Exam webinars, where this particular one was run by Brian and our good friend Russell Brown, who both of these fellows are involved in a lot of the webinars. And you'll see that for that particular webinar, there's a tab that can be clicked. I'm not going to click on that, but to download those associated documents, you get an entire zipped file where all the documents that were used in that seminar. Now, I've downloaded that file already, and I'm going to use a couple of the TNS files that are in that to illustrate what I mean about altering files. So the first one I'm going to do, and I'll minimize that and go back to our slide where we alter data that are on existing TNS files. And I'm using a file that was shown in that webinar. And thank you very much, gentlemen, for producing that for us. And this was one of the files that looked at the concept of moving mean. Now, in this particular file, let's just take a look at the structure. I hope that you all know that you can take a look at the overall structure of a file by pressing Control and the up key. And we see that we've got a data and statistics, we have a lists and spreadsheet page, which it opens with, and then later on a data and statistics page. Now, currently, the file is shown up so that the data from this page, which is from a problem about the months being labeled from 1 to 12, just scroll down there so that you can see how, whoops, that goes very quickly. The months being from 1 to 12 and the data in there for births in a particular town or suburb, wherever it happens to be, are listed there. And then columns C and D are loaded with the moving mean and the moving median. Now, if we look at page 1.2, you can see that the graph is set up to show two different sets of data. the month or the number of births compared to the month, and then the moving median of those months as a different color, a different icon being shown. And what I'm going to do today is to show us how, well, if we go back to alter that file, so I go back to page 1.1, and I'm going to change month to a different value. I'm going to call this years, just for something different, still a time commitment. Go over to, press enter, go over to the heading of column B, and I'm going to label that from births to accidents. Please don't try to read anything into that. And press enter. And I'm going to leave the data in column A the same. Let's say if I want to change this to a new set of data, and I'll just call them out as I enter them. So I have 12, 19, 15, 12. You might notice that the values in column C are automatically updating, as you would expect from this software. 23 after 9, 16, 17, 11, 14, 18, and 21. I think I've all entered that incorrectly. Okay, and the data has changed. But I'm going to go over now and see, well, suppose instead of looking at the moving mean, I want to take a look at the moving median. I know the file says moving mean, but if we go to 1.2, we can alter what we have here. We have to certainly, we don't want to access month anymore. That data is still remembered. We want it to access years. Now that stays exactly the same, but it's now a little bit more relevant. And let's, for the time being, go over to the vertical axis, and by, again, a right-click on that, I'm going to remove that y variable, and I'm going to remove that y variable as well, so that we start off. I'm going to, and well, because there's only one there, I'm going to change that from births to accidents. And at this stage we have those linked up. Now if I wanted to see the moving median instead, I go over here to the right, I add a y variable, and I right-clicked to do that, so remember that that's Control menu. I want to add a y variable, and the one I want to add is from column D, which is the moving median. Now it takes on the same color scheme as the one that I had before. I can change that if I wanted to. But there I've got new data put into an old file, and this kind of thing can happen again and again and again. So it's really depending on what your students are going to find most handy to be able to take an existing file and enter data in. This can be a very, very useful exercise.
There's
also,
of in the download.
Pardon me?
Great to have. There's about a dozen or so of those files that Russell made up, and they're in that download.
Oh, yes, that's, yes, this is really tip of the iceberg stuff. So now we're going to go to taking a look at what happens if you alter another one of the files that appears in that same set, but altering a dynamic notes page, which is really quite a powerful aspect of the Nspire technology. So this particular one that I'm opening up is looking at a file that was written that links to the previous one we just took a look at, but it actually is focused on helping students work out the equation of the equation and the slope or the gradient, and the equation of a line when you're given 2 points. And again, to take a look at the structure of that particular file, it's a 2-page problem. The first one, both of these are notes pages, excuse me, and we're going to just take a look once again. At the overall instructions, you can see that there's a reminder here that while y equals mx plus c is a preferred option, oftentimes in the solutions, particularly for statistical questions, the form y equals a plus bx is required. But some instructions about how to do the editing appears on this particular page, where we edit the blue numbers and then we're able to evaluate, and the pressing of enter at certain points is fine. So I'm just going to go over to that page. Now those numbers were relevant to the previous set of numbers, but I'm just going to say, well, suppose we have two different points, and it might not even be a statistics problem. It might be something in the linear module that they want to be taking a look at. And so let's change x1 to be negative 15. I simply click on this blue. I'm going to get rid of what's there before. I'm going to type in negative 15. And I'm going to press enter. When I do that, then the green value appears, means that particular first x value is locked in. Similarly, I'm going to change y1 to be equal to 10. Press enter. Make x2, instead of being 1, I'm going to make that into 12. Press enter. And finally, 11. Alter that to be equal to negative 5. And press enter. And notice I've got my new calculations for the gradient. Because of the settings on the calculator, I think it was on float 6 and approximate. Excuse me, it was going to give this out as the recurring decimal 0.5 recurring, which we as teachers know is negative 5/9. You may have a need to alter the decimalized gradients to exact values, which you could do by altering the document settings, or you could simply use the other calculations to change from exact to approximate on a calculator page. So, and just noting that the equation down below once again is given, being very careful to notice that if this is a multiple choice question that they were dealing with, they wouldn't have it in that form. They would probably have it in exact form, and so you would need to alter the settings to give these in exact form, keeping that as 5/3 and this one being minus 5/9 x. So the gradient being negative 5/9, kind of hidden in that format, especially for students who have been locked in for years and years on y equals mx plus c form. But that's the way this particular one has been written. Again, it can be a very useful file for students to access when they need to. I'm now going to take a little bit of time to take a look at relational graphing, which those of you who do run version 4 or above have found that this is very useful. And this is found in one of the optional modules in area of study 5, graphs of linear and nonlinear relations, particularly useful for linear programming questions. And just some hints that you'll be able to go back to when you access this webinar again. I'm going to be doing this from scratch. I'll open up a graphs page, and then we'll access the entry edit, and we'll change from a function to a relation, and then we'll take a look at some really nice things that occur with the solve command and the var key. So, and also take a look at graphing some inequalities. So to begin, let's take a look at a sketch of 3x plus 4y equals 12. I think that was part of the advertisement for today's webinar, that we'd be taking a look at equations that are in that particular form. So we'll take a look once again at a TI page, and I've opened up a graphs page which defaults to the functional way, expecting something in a y equals form. But if we go to the menu and then take a look at the graph entry edit, and we notice that item number 2 is for relation, that allows a different format to be entered in. So what did we have? We had 3x plus 4y. 3x plus 4y equals 12. And when we press enter to graph that immediately without the need to transpose, we've been able to see the graph. I remove the cursor away from the line, it still highlights. This equation can be lifted up and put in a different location if necessary. If we open up another page, which is going to be a calculator page, we have a chance to do the transposition if we need to by accessing from the menu and the algebra key, solve. And if I want to solve what I've just come up with, it's been stored as a variable. I go over here to variable, and I pick out this first relation. Now, it doesn't give the equation, but we know what it is from the previous page. The syntax in the brackets is x comma y because it was a relation that used those two variables. And whoops, I haven't put them in the right place. In between, it's very important to put them in between the brackets. So we put x comma y. And because we're going to solve that or transpose it, we have to be able to tell Nspire what we want to solve it for. Usually we solve for y. So there's our syntax. When we press enter, we have it transposed in that particular form. If expanded, that can turn into y equals negative 3x on 4 minus 3, I guess it'll be. I'm going to let Brian talk through what I'm doing here.
Yep. So you saw the transposition here. So, and that's very handy. With the solve, quite often solving, people think, well, that's just going to solve an equation for a single unknown. No, it can actually transpose equations as well, or transpose formulas, and that's basically any formula you think of. You type in the formula, it might be something from, perhaps it could be a physics formula or whatever, and then just comma and put the variable that you're wanting to transpose for. So whether it be for y or whether it be for the x. And it doesn't have to be a function relationship either. It's, as we've got there, relationship 1 with the variables x and y contained in it. And of course that relationship was defined earlier on the graph page. There it is. Yeah, so that's quite a good feature. Quite often I know I've seen students who are used to the idea of seeing particularly a linear relationship always written in a functional form, that is y equals, say, mx plus b or mx plus c, depending which school you went to. But then when they see it as, say, 3x plus 4y equals 12 or 3x plus 4y minus 12 equals 0, it tends to freak them out a bit. But it's very important for them to know that it's just the same thing, it's just represented a different way, the formula rearranged.
Exactly.
So I'm thinking that's the main points you were looking for there, Roger.
It was, and just before we finish here, I just wanted to look at the inequations. If we go back to the graph entry line, and you want to throw in an inequation in the same form, say 2x minus 3y, and say if it's going to be less than, press tab, and, sorry, not tab, escape from that, press control, equals, and choose the less than sign. So 2x minus 3y, whoa, I lost my entry line there, so show entry line, so 2x minus 3y is less than 6, and press enter. And what we get is that shaded region, remembering that the default for Nspire is to shade the true region, not the false region. And if you look carefully at the screen, you notice that because of the less than, you do have a dotted boundary which comes to the fore a bit when you put your cursor near it. And of course the intersection of those two lines could be found if necessary. It's a really nice feature. It prevents students from having to do the transposition first and keeps it in the format that they usually have in linear programming problems. I was going to, but I think I'm not going to risk with the coughing that I was encountering, taking a look at built-in stats functionality. If we have time, we can go back to that, but there is a possibility of doing lots of examination of the statistical residual plots as well as some of these other aspects. Again, you will find lots of these on prepared files, either on the YouTube site that Brian's going to take you through or through some of our previous webinars. But I think I'll now hand over to Brian, and he can take you through the second part of the webinar.
It's beautiful. Okay. Sounds good. So I'll launch into that. I was actually going to start with some Univariate data there because I thought it was quite interesting when I saw on the examiner's reports there. Sure, there's some of those themes that just keep reoccurring, and there's that screen lotto we've gone there. It's interesting. I'll just go back to the examiner's report there. It's interesting to see the univariate data coming up, box plots compared to dot plots, discussion of outliers and fences, where I would have thought that probably one of the simpler parts of the data analysis when we get into seasonal data and time series, and of course regression analysis for all the bivariate data plots. That's a little bit more involved. But I was surprised to see univariate data popping up there. I've got something that I think might address it. And of course we keep seeing these same things. The examiner saying students need to use their reading time better, follow the instructions, make sure they answer the questions, etc. Thank you. So, where are we? I'm jump back to that. Yes, so it's great that Roger was showing you some of the earlier webinars that we've done, in particular the exam preparation one that was done in September last year that Russell Brown had some great TNS files prepared for that. I did one earlier this year that I called Give Me 5, where I talked about 5-figure summaries, which of course are critical for box plots, and I've also built a TNS file that shows the fences and outliers. Now, I'm just going to quickly show you that. So this is it here. And again, if students have this file, I'll show you where you can download it. If they have this, they might want to take it with them into their exams. I think it's fairly predictable that at some stage they're going to be asked to analyse a set of data. In this one I've called it data, that's original. And I've just got half a dozen data points. You see to the right of that, I've got the statistical summary, the univariate data. I've got a box plot. And if we were asked to show that as a dot plot, we can do that as well. So it's a fairly boring dot plot, but you get the idea. So if students need to swap between the two, that can be done. And also histogram as well. What I've got here, a dynamic notes page, and this will change automatically if I change the data. I'll prove it to you. You see, here's my 5-figure summary for numbers from 1 to 6, the median being, the median being 3.5, the lower quartile being 2, and the upper quartile being 5. Here's the interquartile range, and so on. So this is all written in here. If I go back and change the data, instead of 1, 2, 3, 4, 5, 6, let's go, I don't know, 7, 8, 9, and I'll still leave the 4, 5, 6. So if I jump back to this, you can see that that has all changed automatically, and even if I've got a different number of data points. So if I want to add more data points in, you can see what's going on here, or fewer data points. It will still work. Bang, there's your summary. And of course, students can do their statistical summary as well. The box plot will be a little bit out of whack because it's on the original scaling, but hey, I can rescale that. Just zoom that back for the data, and there it is. And so I can get my critical points. And what I've also put in is a calculation of fences, okay, using the lower quartile minus 1.5 times the interquartile range, because the interquartile range was calculated back here. It's all there. The students can take this, here it is graphically, and this will show, oops, I'm messing with the thing there, but this will show the lower fence and the upper fence. And if I've got a data point that is wildly out, let's just put one in. I'll go back to the original data. Let's just change that 7 to a 17. You can see that I changed one of the data points from the graph. Everything is interconnected. So there's my 17, and you can see it's outside the upper fence, so it's an outlier by formal definition. Now, if you would like a copy of that, and I hope you do, there is a section on the Texas Instruments Australia website. I'll get this thing happening. Come on. Where we've got, I'll just open up the website, where we've got senior curriculum with lots of activities that are shared. So I'm hoping by now you've already found under Teachers Australian Curriculum Inspired, then Senior Curriculum Inspired, and most of these have set up, by course, sets of activities where, so here we are, data analysis, sets of activities where if you download you get you generally get 3 documents: worksheet for students, a worksheet for teachers, or, well, the answers plus teaching tips, and a TNS file. Now, mine, called Give Me 5, is not yet published on there, as you can see, but I'm going to give it to you. Here it is. So there's the TNS file that I just showed you. Here's the student worksheet. A bit late in the year to be doing this sort of thing now, but there's the worksheet introducing those ideas. Activities for students. I think I've got a matching activity down here. I talk about skew, positive, negative, all that sort of lovely language. And then the teacher notes, which includes the answers. So you've got advice to teachers here. The answers, you see, to the numerical problems, screenshots, and there's the answers to that match question. If you want to download that, because it's been presented as a webinar, if you go through to the webinar archive, that's webinars on demand, and look for 25th of May this year, you'll see that myself, teamed up with Melissa and Stephen, did this, and there's the download associated documents, just the same as you can do for Russell's. Can I just show you something with Russell's, though? When you download from a year ago, Russell's activity on, so here we are, 2nd of September 2015, it comes down as a zip file. Now, Russell very cleverly wrote this PDF, and every time you click on the little calculator icon, it goes hunting for the associated TNS file, some of which Roger has just showed you. And the problem here is, though, that because it's sitting inside a zip file, it won't work. So you've got to take it out. Take all the files out of the zip file, and what I've done is I've put them here, and you put that further maths, the PDF file, inside the folder with all the TNS files. So then you run it, and then you go to your little calculator icon. Here's one. And you see this is on there, and it will open it up. And bang, so there it is, that appears. And with those dynamic notes. And so that's appearing inside my calculator. A reminder, students do not have to clear their calculators when they go into the exam. they certainly have an active advantage if they've got some good, some cleverly written TNS files. Also, just for the confidence, particularly with dynamic notes, you can go in and you can just change values. Let's change that to 2.5 and press enter, and everything else changes as you go. So what is it for the multiple choice questions? About 90 seconds per question. They need to be able to do these things quickly. Can I just throw in another little comment? I see there's a fellow Ray online from Melbourne, and last year when I was teaching specialist maths, I've told this story a few times, I know, one of my students said, Mr. Lannon, this procedure we're doing here it's extremely algorithmic. It's straightforward. It's an algorithm. Surely you could write a dynamic notes page for this. And I said, yes, I think you're right. I agree with you. And what's more, I think I know the fellow who would have written it, such a page. And I got on to Ray Rosen in Melbourne, and he said, yes, Brian, of course, and he sent it through. My students were delighted. So thanks, Ray. Ray did a similar session to this, 3 nights ago. So what's that, Monday night? So if you're wanting the other subjects in the archive of webinars on demand, you can see these for maths methods and specialist maths all this week. Okay, so we've talked about the Give Me 5 activity. Hopefully that's useful to you. I'm going to jump into a slideshow format here. And so we've talked about the deseasonalizing of data. You saw that from Roger, thank you. I've talked about the box plots. I'm just going to talk quickly about number patterns and particularly difference equations, because that, as you are well aware, has moved into the core this year. Previously, number patterns and business mathematics were separately modules, but that and also the finance are now in the core. Here's the reference from the Australian curriculum, recursion and financial modelling, and you see appearing right through there, first order linear recurrence relation. Your students need to understand what that language means and how to deal with it, and in particularly this type of difference equation format here. What does it mean? Linear, well, we could probably look at this and say, yes, I can recognise effectively y equals mx plus c here, but it's a little bit disguised and from what students might clearly know. What does this first order thing mean? I'll just quickly address that first by saying, hey, do you know what a second order recurrence relation is, or difference equation? Fibonacci sequence, you are likely to be familiar with. 1, 1, 2, 3, you know how this continues, and there's all sorts of lovely patterns and questions from that. But the way any individual number is developed is we look at the 2 previous numbers. There's no formula to say, well, the nth term, although we could develop it, but it's not the nth term of a Fibonacci sequence. It's more, let's look at the 2 previous. So I can say, well, or shall we say t subscript n equals t subscript n minus 1, that is the term immediately prior, added to t subscript n minus 2, the term 2 prior to that. Well, that's all very good, but somewhere we need the starting information. So if I say t0, not t1, but t0, we're calling the initial term t0, and that's because it's the first term we started with before there was any iteration or any changes. This type of approach is used much more in financial and business maths, and that's why we've moved to T0 rather than T1. So this one is a T0, this one here is T1, and I've got enough information there to develop the Fibonacci sequence, and of course we can do various variations of that if I started with different values for T0 and T1. This one, however, as lovely as it is not in the further maths course, because as you saw, you only have to do first order linear recurrence relations. This one is second. Okay, so first means you'll just be going back once. Now, just quickly show you how that's set up. Repeated operations on the calculator. You see the first one, if I start with a number 5, and if I add 3, I'm going to generate a sequence 5, 8, 11, 14. Alternatively, over here, if I start with a number 5 and I multiply by 2, I'm going to generate the sequence 5, 10, 20, 40, etc. And this one here, this is a hybrid or a mix of the two. You may have previously referred to this first one as arithmetic and this one here as geometric. Well, this is both. Can you see that I've got the geometric thing? I'm multiplying the previous number by 2, so 5 by 2 is 10, and then I'm adding 3 for good luck. Okay, it gives me 13. And then I'm taking the next, that's basically the same process again, 13 multiplied by 2, and then adding 3 good luck for good luck. 13 times 2 is 26, plus 3 more is 29. Now this is how these three things are described using difference equations. The initial term in this first one was 5, and the nth term, that's any term you like, will equal the previous term. That's what the n minus 1 means. It equals the previous term plus 3. So let's say this term here, this 14 here, what that equals is its previous term, i.e. 11, plus 3 more for good luck. And of course you know how I can generate the next term and so forth. Same sort of argument here for the geometric progression, except with multiplying rather than adding. And what this has the great benefit of is putting the two together. So in the hybrid or linear function, I've got the nth term being 2 times the previous term plus that 3 more. So what the big move there has been, as we've gone into the national curriculum this year, is we're moving away from these blue formulas that are so, established and dear to us over the years, and sure, that's great, we can still use them, but the emphasis now is on these ones that are above. They're the difference equations. So focus more on this language as you do your exam preparation. We can look at the same sort of thing in a spreadsheet on a calculator. I will show you one, I won't show you the spreadsheet, but I will show you one other thing that's handy, and that's the generate sequence command. So I'll just jump into a calculator to show you that. Got a few things happening here. This one here, if I have, let's go in the list of spreadsheets, let's say I have the number 5. Hang on, no, I won't even bother. I'll just start with a sequence here. So let's say this is my sequence. You see QU, I'll call it, okay, and I'm going to put the data here. If I hit menu, go to data, generate sequence. Now the formula, this is U subscript N, okay, see in brackets there. Well, what that's going to be, I'm going to go 2 multiplied by U N minus 1. So it's a little bit like that subscript idea. When I first saw this, I wanted to expand it, and I had UN minus U, which kind of doesn't make a lot of sense. And then what do? We'll add 3 for good luck. Okay, so what that's doing is that will generate the formula. That's my difference equation. Let's say my initial term was 5, and I'll just do, say, 10 terms. Whether we start here with 1 or 0 isn't particularly important at this point. And there's that sequence generated. Can be handy if you're wanting to set up a spreadsheet where you're wanting to fill down numbers. Of course, there are other ways to do it, whereby using copying cells or cell referencing in a spreadsheet. But meanwhile, back into this. So there we go. And so we've done that one, the number patterns, difference equation. Financial solver came up in the examiner's reports. The comment was that students using financial solver for one application, fine, but get into a bit of strife when they try to do a double application. And here's a problem. There's a fellow called Brian, and let's say he has a car loan of $12,500, interest charged at a particular rate per annum, quarterly compound, and the terms are he's got to pay this thing out in 5 years. So that's all good. Okay. If the question said how much are the payments, that's an obvious question. We could work that out. But the question is, in this case, after 3 years, not 5, he will have reduced the balance of his loan by what percentage? And so this is where there's this double-barrel question that's bringing students undone. I'm just going to jump back to my calculator, and I might sort of be a little bit sneaky here by pushing this across here. Let's put that in there, and I'm going to go for that, and we'll put that up there so that you can see the two things side by side, and I'm hoping the calculator screen's big enough for you. So to get the TVM solver menu, and it's under Finance and Finance Solver, and the number of terms, okay, if I'm going to be, let's first of all work out what my payments need to be, and I'm a little bit slow, but I know I'm doing it 4 times a year for 5 years. Let's say I'm not particularly good at my tables, I'm just going to put in 4 times 5, okay, so it is 20, so that's worked out. And the interest, again, I'm a little bit lazy because it's going to, I'll need to put in here, the interest's compounding quarter, I'll put in 9.5 because it's going to compound, that's the per annum, okay, so we'll work that out. And the loan is to be fully paid in 5, the present value is 12,500, 12,500, so I've got that there. Whoops, what have I done? I know, I should be using my tab. I'm being lazy and trying to speed this up. So I'm just going to biggerise that for a sec so I can see what's going on. Nope. Close the open dialog box. I didn't think I had any, to be honest. Let's see. I'll bring this back again. It might be on there. And hit our tab. Yeah, we're looking good here. Now payments is what I'm trying to work out, so I'll leave that blank for now. Future value I want to be 0 to pay the loan out. Payments per year, let's run with 4. I think I had 1 there, I'm going to get rid of that. Let's go with 4. And down to here, I want that 4 as well. Okay, so let's just run up to payments and press an enter on that. And I've got, if your eyes are good enough, was it $792.40 per month to pay on that. But it's after how many years will I've reduced the balance of the loan by approximately, after 3 years, how much have I taken out? So what we're going to do is I'm going to leave that payment there, okay, and I'm going to go for after 3 years, so that'll be 3 times 4, look, I'll do it myself here, so I'm going to be 12 payments, and what will it have come down to? So the future value, so the present value is that, so the future value now is what I want to know, so I'll press enter on that. So I've brought it from 12,500 down to, let's see if I can get this here. I couldn't show the whole thing before. Nope. Obviously I've got dialog boxes open here somewhere. So the trick then would be to take the 12,500, subtract the $5,712, and then that's what I've paid off, and so then I have to take that amount and divide it by the original, I'm just going to get that out of the way, so I'll have to divide that by the original amount. So here are the calculations in screenshots, and what I've set up there, and that's the final calculation once I've worked out that I've taken this much off my car loan. So is that two-stage thing? So one use of the financial solver, students were generally good at, but a double use of it. So that trick, and particularly if we've got multi-step questions, then there's a requirement for students to take a result from one part and use in the next. Now, I don't know about you, but I'm not into this multiply by 100 over 1. I believe that this here is the value, and if I want to see it as a percentage, percent by definition is per hundredth. So I look to the hundredth place, and I see the 4 in the hundredth place, so I'm going to have 54.3 hundredths, or 54.3%, is the way I approach those ones. Okay, so there we are. The last one there was talking about the relational graphing, which Roger has already showed you. And I wanted to just show you one other trick. And that is directing students to the YouTube site, where a lot of these webinars, courtesy of Texas Instruments, are chopped up into bite-sized little snippets. And you see there's webinars for teachers, VCE mathematics exam readiness, bite-sized, just little chunks on, okay, so how do you do that thing in trigonometry? How do you upload photos if that's something they were looking to do? And this one here are full-on webinars that are being at the moment transmitted into Western Australia. So have a look at some of those. Where do you find all that? I'll come back to the original website. So that's the webinar part of the website. Let's go back instead to the main part. And here we are on the front page of the Australian website. Just check where it says site here. If you've got that American basketballer first of all, you've gone to the American website, change site, and tick Australia. Australia is first and the United States is last. I like pointing that out to people. And
I'm just going to clear my throat at this stage.
Good on you, Roger. and so those main links here, webinars, of course, where you can download those TNS files, and this one here. And we're actually finding that students are really, really giving this a lot of work. They're jumping in, particularly on the YouTube. If you want to know the link to the YouTube, it's actually, well, first of all, there's little short ones here. So this is great, and that's so you got the little clip there. That's just a 6-minute clip. Okay, but pick your topic. Pick your topic from whichever course, and here they are. Look what you want: normal distribution, univariate data, least squares regression, matrices, residual plots, etc. So that's just a great resource there. And if you want to directly go to that YouTube site that I showed you, it's linked right here. So, still plenty of work to do between now and the exams. I've got a daughter in Year 12, and she would be able to tell you right now exactly how many days or how many hours it would be till her last exam. But there's still a lot of work to be done, so I'm going to hand back to Frank and wish you best with your exam preparations.
Well, thank you, Brian. Thank you, Roger, for a very informative presentation with lots and lots of good ideas. So hopefully my screen will appear. I have been having some problems. I just want to point out some follow-up for the webinar. You will be getting an email in the next day or two, and it will include a link to your PD certificate. It will also have a link to some PD that's coming up. There's a Learn, Energise, Connect coming up on the 19th of September at Toorak College in Mount Eliza, one later on in the year at Mount Waverley, and of course there's the MAV conference coming up, which will have lots and lots of TI instructors presenting. You'll also get links to the Australian Curriculum Inspired and the Senior Curriculum Inspired, which Roger and Brian have been speaking about, with lots of ready-to-use activities. As well as that, a link to the YouTube channel that Brian has been looking at. And lastly, Texas Instruments does value your input, your feedback, so at the end of the webinar, please take a minute to provide feedback on the page that will come up when you close WebEx. Okay, so until next time, thank you and goodbye.
Good, thanks, Frank.
Thank you, guys.
Good night, everyone.
Night.